Rocket Lab, Electron. Stronger together launch coverage. All right, let's see what we got. Switches over to Sign Tech. I 100% had to invert control fins on my rocket because they were controlling backwards now. Yeah, see, something is strange because my plane flew just fine. We flew the plane in the patch. It flew just fine. But that thing doesn't. That thing flies like something is completely... We're getting phantom forces from something. The center of mass, center of thrust is completely lined up. And the center of lift is directly over my center of mass. Which shouldn't make that much of a difference. I just don't understand why it hates... Like, dude, that thing, once you pitch over, that's it. It just noses into the ground like somebody's holding the S key. You know? Don't get me wrong, I did put the probe core on upside down. But putting the probe core upside down, compounding with what already happened, definitely didn't do me any favors. So, I don't know. We'll see. This is a basic stick rocket on an SRB with 4 control fins. Okay. Yeah, so, I mean, there is some evidence saying that it could be just the patch. And Agalex, you were saying, yeah, they did mess with stuff. They did mess with stuff with wings and whatnot. I had that control bug. It went away after I restarted the game. Really, Deadvard? Huh. That's weird, man. Yeah, I don't know. Maybe it's the craft file. Maybe it's the game. Who knows? Maybe we just got to give Kerbal a restart. Maybe I should scratch build something new. Yeah. I kind of want to just build planes anyway, dude, so... Let's, I want to do that when we jump back into KSP. Would you guys be cool with that? I want to mess with the procedural wings and really make something ridiculous. Yeah, Lunar Soul, it could be. Yeah. Let's build planes. KSP TV, planes! Yeah. I don't know, man. I'm like 70% that I changed something and like maybe 30% that something is... I mean, I don't know. It could be... It's 50-50. I don't know. Maybe I rushed it. But we'll build a new one. Or we'll build a plane or something. We'll see if something screws up with that. Wings with Thursday. Not a plane, but wow. I do like that, chillin'. That's pretty cool. That actually doesn't look too bad, dude. Hear me out. What about a fresh install with a new patch? You want me to fresh install? The pitch happened because in flight you got tail heavy. I know the center of lift, center of mass markers may not be showing it, but that's the behavior in flight. There's a mismatch for some reason.
Discovery.
Yeah, so Aqualex, you keep saying you're tail heavy, and I told you. How could it be more tail heavy when we took stuff off of the tail? Wouldn't that mean that the one that launched yesterday was more tail heavy than the one that we have now? Why did that one work and this one not? Do you understand? That's kind of... I think that's a weird argument to make. I understand the behavior. It definitely... I think it might have to do with aero. Something is weird with those wings. And we clearly saw that something was weird with the aft control surface, but I don't know what it is. Like, this is why I'm not 100% sure what this could be. That's why I'm like 50-50. It could be the craft file. It could not be the craft file. I don't know. You know? That's kind of the... But I will say this, dudes. That's kind of the reason why I'm not doing, like, mission mode or anything right now. Let's just have some fun, because updates to the game can break stuff. That's kind of the nature of early access. You know what I mean? So, you know, we'll see. You took wing surface off the back. Yeah, to get the center lift and center mass to line up. Who knows? Do you know what's with the 3D printed rocket? Monday. Kulima, 1 day. One month. Rewind 10 seconds. Monday is when it's gonna go. Yep. We broke another turbo. Jam, maybe you should adhere to the same type of rules that I adhere to when I'm playing Kerbal. If it's broken, if you keep breaking things, be absolutely sure that it's not your fault. Be absolutely sure it's not your fault before it breaks. Before you go say, hey, this thing is junk. It's Wednesday for relativity. Cool. Fast forward and roll ads. I'm not going to roll ads. We roll ads at T-minus 10 minutes. I did a dumb and forgot to plug in an oil line. Plug in an oil line. Yeah, 100% your fault. Yeah, there you go. All right. Are we up to speed? Come on, get up to speed here.
And delivered their satellites to orbit with pinpoint accuracy.
Right. So this is Electron
These
here.
3 Cluster 6 satellites are already providing useful Earth observation data from their new home in space. That mission marked a new era of dedicated small launch from U.S. soil for satellite operators.
So here, I'll say it. So this is the mission dubbed Stronger Together carries the Capella Space Capella 9 and Capella 10 satellites. The improved satellites are about twice as large as the Capella 1 prototype to accommodate a bigger sensor aperture for the X-band synthetic aperture radar. Oh, they're SAR, so they're Earth observation satellites. This is going out of Wallops, guys. Yeah, there you go. Wallops Island, second Electron launch from Wallops, which is pretty cool. I don't think they're going for any recovery here. Let me check. No, this Electron will get expended.
Streamlining operations across small and large launch as we build out the future of responsive space from Wallops. Construction is currently underway on the Neutron Production Complex and its launch pad, right next door to where Electron is currently standing.
Yeah, Neutron's pad will be right over here.
In fact, while we're preparing to go to orbit today for our customer Capella at Launch Complex 2, across the world in New Zealand at Launch Complex 1, preparations are already underway for our next launch for another customer. Our teams at both sites are looking forward to a busy year ahead.
That's in New Zealand, dude.
Speaking about being stronger together, though, today from Launch Complex 2, we are launching a dedicated mission for Capella, a leading provider of commercial synthetic aperture radar, or SAR, imagery. SAR is a form of radar that is used to create two-dimensional images or three-dimensional reconstructions of objects, such as landscapes. We launched one of Capella's very first SAR satellites on another mission back in August 2020 on our 14th Electron mission called I Can't Believe It's Not Optical.
Our mission today would deliver 2 more of Capella's latest SAR satellites to orbit, enabling them to deliver the highest resolution, highest quality SAR imagery commercially available, empowering organizations across the public and private sector to make informed, accurate decisions based on what is happening across the Earth.
The Capstone mission that Electron launched is basically a small CubeSat that is trying to find Gateway's final orbit. There's a CubeSat called Capstone that's looking for a rectilinear halo orbit. It's basically they parked it in Gateway's orbit out there. It was one of the first Artemis missions, technically.
Let's rock and roll.
We learn really fast.
How big is it?
And we built satellites.
Ronnie, this is a small rocket. Electron's tiny, comparatively like Falcon 9 and stuff. Not very big. Maybe about a meter wide, 3-4 feet, something like that. 3 to 4 feet. Excuse me. Maybe about this big. It's not a big rocket. It could fit in a tractor trailer. It could fit in a 53-foot trailer, if that makes any sense.
Highest resolution SAR imagery in the world in the most compact form. We're the first one that's able to do real-time tasking, which means people are going to be able to get their imagery as quickly as it's possible. So it's not just that we've done something as complex as putting a satellite up. We put up the best satellite in space. And we've done that with just 100 or so people in a day.
Is it choppy for anybody else? The stream's super choppy.
We're thrilled to be flying Capella once more and grateful to have signed an additional multi-launch deal with them coming up in 2023. These 4 missions are planned to lift off from one of our 2 pads at Launch Complex 1. with the flexibility to launch from right here at LC2 in Virginia, if campaigns require. All right, as we approach T-minus 12 minutes to lift off, our operators will run through the final
synthetic aperture radar
no-go poll by this mission's launch director.
Black magic.
Let's hand over to mission control.
Are you a wizard? Yeah, dude.
Sorry, and check in on how we're tracking for launch. We'll be back with you shortly.
Put it in 720.
All right, as we approach T-minus 12 minutes to lift off, our operators will run through the final no-go poll by this mission's launch director.
Let's see if operating at 720p is going to do it. It's not you. The stream is very choppy. Yeah. Are you familiar with gravitational lensing? Of course, Squishy. Yeah, James Webb did that. Pretty cool. Using another solar system as a magnifying glass. Wild stuff, dude. All right, let's see.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
Mars CE.
POS, what's his job?
RCE is go.
Mars Ops.
Mars Ops is go.
Mars 1. And NASA GSO.
Yeah, okay, well, okay.
And NASA RSO.
Point of sale. I'm pretty sure that's not what that guy does.
MM is go.
And LD Sub.
LD Sub is go.
And NASA TD.
TD is go.
The go-no-go sequence is complete. We are T-minus 11 minutes, 9 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
So as we approach T-minus 10 minutes and 40 seconds, Mission Control are reporting all systems on the vehicle are healthy and will be proceeding with the remainder of the count. We are still targeting liftoff at 18:38.
So, fellas, what I'm going to do here, 10 minutes out from a launch, I'm going to roll pre-roll ads, so pre-rolls get disabled. So if people come in for the stream, or if people see in the launch, like they come in at the last second, right? I'm going to, they don't get, I'm going to run ads so they don't get an ad right away. Like, because nobody wants to come in and see a thumbnail of the rocket launching, right? And go in and here's your ad for, when a man comes on the TV, tries to tell me how white my shirts can be, but he can't be a man because he doesn't smoke the same cigarettes as me. You can't get no satisfaction with these pre-roll ads, you know what I mean? So I'm going to go ahead and run the ads so people don't get ads during the launch. Hot Pocket ad is better than a rocket launch. I freaking can't stand ads for what it's worth, guys. I know that that's the business and that's how I get paid, right? Like, but I'd rather get paid with your sub money, But yep, it is what it be, so it do. That's the game, so we'll play the game and we'll be good at it. So we're inside of 10 minutes now. If you're wondering about Electron's a 2-stage Keralox rocket, so it's using kerosene and liquid oxygen. That's the Udvar Hazy Museum. What the heck?
Build and launch their own model rockets with the support of our very own rocket.
Okay, that's cool. It's a 2-stage Keralox rocket. The cool thing about Electron is that it's made out of carbon fiber. The whole thing is carbon fiber. First stage, second stage. It actually makes it super freaking light. The other cool thing about Electron is that it's electronically fuel injected. It has EFI. Yes, you heard that right. EFI. I know what people are going to say. Wait, don't all rockets have electronic fuel injection? Well, no, not necessarily. Electron is one of the only rockets flying right now, or if not the only rocket flying, that uses electric fuel pumps. It's got EFI. It's got electronic fuel injection. Instead of using a turbine and a gas generator to spin fluid impellers, the turbo pumps, to be able to move the oxidizer and liquid fuel to the engine, which is basically what most rocket engines do. Most rocket engines is basically a turbo shaft or something like an APU on an airplane attached on an axle to an impeller, hence turbo pump. This thing is it's electronically fuel injected. So it's using a brushless electric motor that's about yay big. That's what's spinning the impellers on the 9 Rutherford engines in the first stage. And the single one on the second stage too. Yeah, electronic fuel injection. I'm pretty sure it's the only rocket in the business that flies with that. Can you turn it off easier? Yeah, sure, Irish. Yeah, of course. Part of that, but now because Rocket Lab is because they're using electric motors to deliver the fuel, there's batteries on the first and second stage. You'll see this particularly with the second stage. The second stage has a set of batteries that are hanging off the back of the second stage right here, not right there. That's the bottom of the LOX tank. Right here. And then when we're up in space, they'll actually jettison the batteries. They'll jettison dead batteries, and because they have their batteries in parallel, right? And they'll hot swap over, and they'll jettison 2 of the dead batteries. Now, don't worry. They burn up in the atmosphere. They're not going to come back down. Does it have a Terminator X too? I'm sure it has some kind of custom fuel injection. I'm sure it does. T-minus 7. We're inside of 7 minutes. Hidgy, it's right over there for you. Sorry, the YouTube stuff is kind of getting in the way. No spin-up time on the injector. No, Bruce. Instant fuel pressure on these rocket motors. You'll see it when Electron goes off. The rocket engines basically go from nothing to in half second maybe. Now with other rocket engines, it usually takes a second to spin up those turbines because it's like throttling up a jet engine, right? Zzz, you got to spool the turbine. Nope, not with this thing. It's just like, I'm on. Bye-bye. This little guy will get out of the hole real quick. Pretty damn fast for an electric for a liquid fuel rocket that's this big. It's pretty damn quick.
On orbit with a Rocket Lab component.
Yeah, they'll be like 3, 2, 1 ignition, and it'll get out of the hole like a solid rocket booster. Guys, did you see that? Look, they did helicopter on Mars. Did you see that? They did a helicopter on Mars. Did you see? There it was.
Broadband connectivity. And of course, NASA's capstone mission, which was a pathfinder to Artemis's mission to the moon. Since acquisition, we've been able to...
Proton also has a really fast engine start. Well, Shinar, Proton is not using electric like this. Proton uses hypergolic stage combustion cycle, which still is kind of wizardry in my mind, but yeah. Stage combustion cycle hypergols. Yeah, that's what those Proton motors, the Proton engines do. Does that have cost benefits, the EFI? Synonymous, it is a pretty interesting way to do it. If you're making small rocket engines, then yeah, sure, absolutely. But for the most part, when you start to scale up, even Rocket Lab with their Neutron rocket, it's using a conventional turbine. It's a more conventional open cycle engine. If you scale up the rocket engines, there's no electric motors that can spin that fast. Yeah. A jet engine can spin faster than an electric motor. Electric motors do have their theoretical RPM limits. Now, there is one guy that is kind of working on trying to make an electric motor spin at higher RPMs. Here's one guy. He likes birds or something. Bird applications or something. I don't know. There is one guy that is working on that with tightly carbon wound copper coils on an electric motor. So there's theoretical applications there, but once you start scaling up with conventional rocketry, it really doesn't, like a conventional, you're trying to use like an industrial electric motor for like a huge rocket engine. You're talking an electric motor that needs to spin at like 60,000 RPM if you want to do anything. Well, not even 60 is like stage combustion. Like that's Raptor. Raptor's turbines spin that fast. We're talking like 30,000 RPM. I'm not sure there's an electric motor out there that's light enough to be able to do something like that. You know, I'm sure there is. Like I said, there's one guy, Bird App Man, is working on that. So who knows? Anyway, we're inside of 4 minutes here. I'm talking about the Model S Plaid motors. The Plaid motors can spin extremely fast. That's why Plaids can go so quickly. Am I a turtle? No. Not since the last time I checked.
LD GC countdown.
Go GC.
Stand by LD.
Oh. Ground control just called the launch director and he said, "Hey, are you there?" And the launch director said, "Yeah, what's up?" And he said, "Oh wait, hold on a second. When was the last time you checked?" Yes.
LD GC countdown.
Go ahead, GC.
ECS disabled, pad auto sequence armed, pad ready for launch.
Roger,
Environmental control systems on the rocket are disabled.
Operators
The
LD on
rockets go for
countdown.
launch.
From now on, there should be no red flags on your critical LCCs. Beacon LD.
LD Beacon.
Confirm all expected flight computer ASGOs are green.
Confirmed.
Beacon, lock auto sequence and confirm.
Auto sequence locked.
Okay.
All operators, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Launch director reports go for launch. Nothing on the computers or saying anything with the rocket is out of line. Everything is honky dory. The auto sequencer should start in 3 seconds. 2, 1. Report go.
TS is green for flight.
Here we go. Hang on, we're in for some chop. Peace streams. Okay, so now that the auto sequencer is on, everybody that's on consoles, like sitting at the computers, like people that sit in behind the computers, they're basically just watching the show at this
complete.
point.
System is in recirc.
The auto sequencer is a computer that basically, it's the flight computer on the rocket. It's the brains of the thing. Now it's controlling all the functions. The reason why it's called a sequencer is because that a sequence of events has to go in the right way for the rocket to get to space. I.e. like lighting engines at the right time, right? Or letting it go off the pad at the right time.
Anti-geysering is disabled.
It would be better to have a computer control all that rather than people flipping levers, you know, like some steampunk style rocket. Okay, flip the lever. Okay, flip that. We're good. We're good. The auto sequencer is a computer that's controlling the sequence of events required to get into space. Can you imagine? Flow the lever. Okay, click. Oh,
Stage 1.
Flip the wrong one.
Press for flight.
You don't want a race condition.
High flow engine purge enabled.
Might be a dumb question, but have launches always been done by computers? Actually, Soltis, not all the time. Not by a digital flight computer. The early rockets were mechanical computers, and that went about as well as you thought it did. And then they switched to tubes. But what they used to do back in the day is have a rocket basically
T-minus 20 seconds and counting.
A rocket would basically be radio controlled from a computer on the ground because there's no way you could have put a computer on the top. Yeah, that's how they used to do it.
Deluge activity.
10 seconds. And then they switched
8,
to digital when the Apollo
7,
program came around.
6, 5.
Here we go.
4, 3.
Sound suppressor
2,
is on.
1.
Send it.
We have liftoff.
Bye-bye.
Stage 1 propulsion is nominal.
They're getting pitch over.
That's nice. See how fast it goes? The electric motors are like, on. Okay, bye, I'm leaving.
And we're flying. Our 34th Electron vehicle is in the air and on the way to orbit after lifting off from Launch Complex 2. You can see the exhaust from those 9 Rutherford engines glowing bright as they propel the vehicle with Capella's satellites to space. Now that Electron has left the pad, its next milestone is max Q, the moment when the density of the air around the vehicle and its acceleration through that air creates the maximum aerodynamic pressure that the vehicle will experience in flight. You'll hear Mission Control announce this milestone soon enough.
Man, that thing is really booking. So because Electron,
max Q.
Because Electron's so light, you can actually see the thing moving around in the wind. So if it seems like it's kind of doing this, it's just getting blown around. That's totally normal. It actually, see?
As you may have heard from our mission operator's call there, Electron has now passed through max Q. The vehicle has throttled back up to a velocity of over 1,000 meters per second, just a fraction of its maximum velocity as it proceeds to orbit. We're about to reach another 3 milestones in the flight, and each will happen quite quickly, so we'll explain all 3 in one go. To start, we need to separate the first stage of the vehicle from the second and third stage, also known as the kick stage, which holds Capella's satellites. The first stage is essentially a large fuel tank. Once that fuel is depleted, we jettison the tank so that the second stage can carry on to our orbital destination. To separate cleanly, we need to throttle down those 9 Rutherford engines on the first stage. This is known as main engine cutoff, or MECO for short. Once these engines have throttled down, the first and the second stage separate. Next, you'll see the vacuum optimized Rutherford engine ignites to carry the second and the third stage the rest of the way into space.
Miko confirm.
Stage separation successful.
Stage to ignition.
Miko, stage 1 separation and stage 2 ignition confirmed and completed. Our 34th Electron mission is progressing nicely, and we're ready for the next set of checkpoints in flight on the way to delivering Capella satellites to their place in space. We are listening for the call to confirm that Electron's fairing, the pointing protective shell at the top of the rocket, has been jettisoned to expose the satellites in preparation for deployment.
Fairing jettison succeeded.
You can see it there on your screen. That's confirmation that the payload fairing has been successfully jettisoned and Capella's satellites are now exposed to space. Electron's second stage is continuing to orbit, travelling at speeds of over 8,000 kilometres per hour and currently at an altitude of over 100 kilometres.
That's another milestone checked off. The fairing is a millimeter-thin shell that serves a vital role, protecting the payload's inside from the awesome aerodynamic forces it sees as it breaks away from the atmosphere. Now that we're in free space, we can shed that extra weight to help maximize Electron's acceleration into orbit. Sitting on top of Electron, each payload might feel up to 8 times its own weight due to those smooth accelerations. As part of the structural analysis team, our job is to prove every component on the vehicle is tough enough to withstand the stresses of all those forces, pressures, and vibrations on ascent, while still being a lightweight and elegant solution.
Yeah, MotoKid, I got you. Staging was good. Excellent. So yeah, see the thing with the tinfoil around it? It's not tinfoil, it's Mylar wrap for better thermals. You don't want to overheat your batteries in space. See that thing over there? That's going to pop off. It'll... Man, battery, you really fell off. It should be happening, I don't know, maybe another minute? You heard it, but you couldn't see it. Nice. Why couldn't they go last week when it was dark?
HVB discharge nominal.
Rocket science do be like that. High voltage battery discharge is nominal.
T plus 5 minutes, and it's time for the next set of checkpoints in flight as we progress towards mission success. Next up is a milestone unique to Electron, the battery hot swap. You might already know that our 3D printed Rutherford engines are also distinct for another reason. They are powered by electric pumps. These pumps are powered by batteries, which eventually run out of juice. This is where the battery hot swap comes in. We need to swap the used batteries out with another fresh battery and jettison the expended ones to free up some weight, all while keeping that stage 2 engine running smoothly, which is why we call it battery hot swap. Sometimes you can catch a glimpse of these battery packs falling away, so keep an eye on the right side of your screen. While you do that, we'll listen in from the call out from Mission Control.
8 seconds remaining. Discharge nominal, approaching hot swap in roughly 30 seconds.
Shuttling down. Yeah, the batteries will burn up in the atmosphere, dudes. Watch, ready? Battery hot swap confirmed. Bye-bye.
Hot swap successful.
Yeah.
Stage 2 propulsion holds nominal.
So, John, how my garage is kind of set up, like due south, dude, there's, like my neighbor has a huge open plot of land with no trees and stuff, and, like, I'm kind of on a hill, so the garage is kind of up high, and then there's a field down low, so I can see low on the horizon. Looking due south, like directly due south. It's just by sheer coincidence, dude. I can see Starlink. When Starlink flies up the coast, I can see it. Anything that goes up the coast, like to the ISS, we could see all that. I could see the stages. I've got pictures of them before. But yeah, I do have a clearing due south, so I can see low on the horizon, but there's just too many clouds.
In 10 seconds into Stronger Together mission for Capella.
I'm saying I have the high ground. It's over. It's over, Chatterkin. I have the high ground.
Electron continues to make its way to orbit.
What rocket is this? Electron.
6,000 meters per second.
You don't know because you're from Finland. Terve. It's Rocket Lab. Electron, dude.
6,000 kilometers per second velocity.
What's the lore behind Electron?
Stage 2 propulsion still.
The reason why it's called Electron is because it's using electric motors to pump the fuel. Guys, that's the big one. Rocket Lab is using what's called their own proprietary rocket engine design called Rutherford engines. Rutherford engines are named after Ernst Rutherford. And they basically have a gigantic electric motor. And I say gigantic, it's about this big because the rocket engine is not very big. These are tiny rocket engines. Electron is a small rocket. And they're using an electric motor attached to the fuel pump to push the fuel into the engine. Usually rockets use something like a jet engine or a gas generator or a turbine or something, or a gas generator and turbine. So you get like a turbo pump. This thing is EFI, electronic fuel injection, which is pretty cool. That's why it's called Electron. The thing is also completely made out of carbon fiber, which is actually cool.
Coming up next, the engine on Electron's second stage will throttle down and shut off before the final stage separation. From there, we'll go into a coast phase in an elliptical orbit for about 40 minutes or so.
So this, oh boy, need more coffee, more coffee, more coffee, more coffee. How does one get a job in mission control? I don't know. Are you talking about NASA or just a flight controller here? You got to be a pretty damn good engineer to do that. Saves weight, I guess. It saves weight if you're on a small scale, Soltes. Electric engines don't really scale up very well. You know, and electric motors don't spin nearly, big electric motors don't spin nearly that fast. There's Seco. Second stage engine cutoff, SECO.
The space-optimized Rutherford engine on Electron's second stage has now throttled down.
So in the case of Electron, because it's small, it makes sense. Not so much with a bigger rocket.
Stage separation milestones for this mission are complete. The next phase of the mission takes a little longer than that action-packed first 8 minutes after launch, but it's worth the wait. Electron's kick stage, with payloads attached, will now enter the coast phase that Lakita mentioned, as it propels the payload in an elliptical orbit towards the apogee requested by our customer, Capella. Once it has arrived at the requested orbit, the small but mighty Curie engine on the kick stage completes one final injection burn to raise the perigee of that elliptical orbit so that the orbit is circular. After circularizing this orbit, we can then deploy Capella's satellites and wish them well as they settle into their new home in space. We will have a simulated view of this payload deployment, plus live feeds from mission control. So stay with us on this webcast.
When the when those smaller electric motors go, they go. But it's hard to do that with the amount of fluid that you'd need for a much bigger rocket engine. It's not that bad with a small rocket engine. It's just when you start scaling up that electric motor, RPM becomes a little bit of an issue. That's the reason why, like, Teslas, for instance, you take a Tesla to the drag strip, right? You put, like, Corvette up against it. A Tesla Model S will, like, burn a Corvette in the quarter mile pretty badly, actually. But the Corvette has a much higher top speed. Turns out that spinning explosion device can actually go faster. Now, to be honest, if you had the Tesla with a transmission, that might change things, but I digress. Do they plan on using EFI with Neutron? No. Apollo, I want to be very clear. They don't call it electronic fuel injection. I call it that because like all modern gasoline cars have a pressurized fuel delivery system with an electric motor making pressure inside of the fuel line and injectors that are on an electric solenoid that open and close to spray the fuel. They use a back pressurized line. That's electronic fuel injection. Rocket Lab is doing the same thing, but it's doing the same thing with rockets. And I'm not sure the terminology carries over. Just in case anybody was wondering, Rocket Lab does not call it EFI. They definitely don't. But it is. It's EFI. I think that's funny. You know what I'm saying? Really, I was under the impression that the Tesla's matching top speeds. The Plaid, Aqualux. The Plaid can. Sure, absolutely. The Plaid will, but that's because the Plaid has an electric motor that's actually wound with, like, carbon nanofibers or something. It's not called nanofibers. They're not nanotubes either. They wrap the electric coil in the electric motor with carbon fiber, and it's a very thin layer, just enough so the copper on the coils on the electric motor can spin fast enough and they don't actually delaminate at high RPM. That's the problem with an electric engine. You can make an electric engine spin that fast, but mechanically it'll start to come apart. Did you see the rocket? I couldn't see it, dude. No way, Gil. I didn't know that. You never told me that before, dude. That's cool. It's carbon fiber. Yeah, composite overwrap electric motor. Yeah, they use the same type of thing to wrap a COPV. They wrap the coils in it. I guarantee you SpaceX had something to do with that. So, Argolex, the Model S Plaid, that can actually go fast. It'll go very fast because the motor can spin way faster. Centrifugal force is the reason why the motor's silent. That's it, Ronnie. Yeah, the coils. Because think about it, dude. It's just an electric motor. The spinning part of the electric motor is just a copper coil attached to a shaft, right? Like it's wound, right? And because it's wound, it'll delaminate at high speed. You spin it really fast, it'll just come apart. It'll just untie itself. So if you wrap it in carbon fiber, like what Tesla did with Model S Plaid, then yeah, you can spin it way faster. Oh yeah. Oh, yeah.
Discovery, go at throttle up.
Soltis, Tier 1. Welcome to Mission Control. You go at throttle up. Makes sense, just never considered it. Yeah, it kind of blew my mind, dude. That's cool, Gil. I never knew that. That's freaking cool, man. Problem was solved with the axial flex motor. Oh, yeah, no, that's cool, man. Which is even more crazy since the rotor is mostly solid steel. They have to prevent it from coming apart. Yeah, that's crazy, right? I made the switch from gas to EV in December. They sure are quick. Yep. Yeah, oh yeah, they can get going because you get that instant torque. But yeah, maybe someday, dude, we'll see more rockets with the FI. If they can make that tech light enough and spin fast enough, yeah. And then, of course, there's the whole... Every single person that doesn't like electric cars, well, the batteries are really heavy. Batteries are really, yeah, they're working on that. Give it some time, right? And take it from me, I like gasoline cars. All my cars have V8s in them. I don't drive them often, but yeah, the batteries are too heavy. Yeah, okay. Also, sorry, guys. No, I'm not saying batteries are too heavy. I'm saying everybody says that. Oh, I know the science behind it. Electric cars will catch up eventually. Well, not eventually. They're pretty much there. But I digress. You know, when it comes to rockets, that's where we're talking about. Like cars, it's not that big of a deal. But with rockets, your mass margins are so ridiculously low. You make a lot more. If we could figure out a way to make lighter weight batteries, then yeah, I don't see why you wouldn't be able to build like a heavy lift launcher that has electric fuel injection like Electron does. It's a problem. I mean, one, nobody's working on that. Two, the scalability is kind of an issue. But I don't think that, okay, let me put it this way. I don't think that's any particular engineering challenge that can't be overcome. There's no law of physics saying you can't do that. You know what I mean? Just like there's no law of physics saying that an electric car can't be comparable in range to a gasoline car. Of course it can. Of course it can. People that say that, oh, batteries are too heavy. People that say that don't understand physics. And yeah, I'm not going to say that batteries don't add weight. They absolutely do. So does that cast iron block. Well, the cast iron block in my cars add weight. I don't know about that. I don't know about you guys. V8s drink a lot of fuel. Yeah, T-Man, see, that's the thing. V8s drink a lot of fuel, but you put in what you get out, right? Well, you really don't, but they drink a lot of fuel, but they also give you a lot of torque. Problem is converting all of the the impulse energy in that gasoline, converting that to mechanical work is very inefficient, even by today's standards. But there's not really a better way to do it except for the electric motor. I think the electric motor is pretty good. I get connecting rods out. Yeah, that's when you deliver a little too much. Can you see a launch from Canaveral? Closer, it really depends on where it goes. So, launching from the Cape right here. The Cape has a really wide range of launches. that wide kind of array, if you picture it kind of like a hemisphere almost, right? Like take that shape and kind of cut it in half, right? The hemisphere, it's actually not a hemisphere. There's a boundary that you can't launch out of the Cape going this way because you'll fly over, you know, like Detroit, for instance. You don't want to fly a rocket over a populated area, right? So they fly out of Cape Canaveral. They can go either this way at its maximum to the north or this way at its maximum to the south. There's actually a launch corridor that goes this way, and it goes over Panama right there, and then it goes out and around, right? And then there's no launch corridor that goes down here. There's another launch corridor that actually looks like this line almost, goes out over the Atlantic, right? Now, a launch that's going on the polar orbit launch corridor, I'm not going to be able to see. I'm up here where my mouse pointer is. You know, I'm on Cape Cod for the most part. If you're from the U.S., you know where that is, or you don't. It's this little thing that sticks out right there. If you're from Europe, yeah, just look for the thing that sticks out. That's where I am, right? So if something is going up the northeast corridor, right? So 52 degree flight azimuth, 51, 54 degree flight azimuth, anywhere in there, I will see it. Oh yeah, if it's a clear day, I can see it. Oh yeah, see the rocket fly by. It goes right over. Well, it doesn't go right over me. It goes right next to over me. Yeah. The best ones for me, dude, are Wallops launches that go to the ISS, because the ISS's orbit is actually kind of super inclined like this. Now, okay, so we've been playing a lot of Kerbal lately because Kerbal 2 came out. Let's learn a little bit about orbital mechanics while this thing is coasting. So the equator, everyone knows that it's the equator. It's the hemispherical center line of the Earth, right? The equator goes right here, right? So when electron crosses the equator right here, the angle that it makes, right, relative to the equator, right, that angle right there is what's called its inclination. It's the tilt of your orbit relative to the equator, right? So this right here is a pretty inclined orbit. It's actually, yeah, that's pretty inclined, dude. The reason why is, well, Earth is that whole oblate spheroid shape, so this thing looks like it took a southeastward trajectory. If it launched due east, it would go this way and then it would start going down, and its inclination would actually be higher. The inclination of an orbit is kind of correlative to your latitude, right? So Wallops is actually pretty far north of the equator. I think it's like 30 degrees north latitude or something like that. That's just a guess. It's probably not 30. The Cape is 27, so it's probably like 40 or 50 or something. I mean, I'm up here. I know we're like 53 inclined up here, so let's just say it's 45, right? So get this. If you launched out of Wallops Island, so Mid-Atlantic Regional, you'll hear them talk about it. They say Mars, that's Wallops Island, Mid-Atlantic Regional Spaceport, right? If you launched due east out of Wallops at 45 degrees north latitude and you launch perfectly due east, that's going to put you into a 45 degree inclined orbit. The Cape is 27.5 degrees, or it depends on the pad. The Cape is big enough where the southernmost pads will actually give you a different inclination than the northernmost pads by like a degree. So it's 27, right? You're 27 degrees north, so you're 27 degrees latitude off of the equator. If you launch due east, heading out, so flight azimuth of 90, if you launch due east out of the Cape, you're going into a 27 degree inclined orbit, right? So the launches that go out of Wallops that actually go to the ISS, and the ISS is 51 degrees inclined. The ISS is 51 degrees inclined, and it's in such a tilted orbit relative to the equator because it's designed to be accessible from all of the international partners that launch to it. We can get at it from the Cape. The Europeans can get at it from a French territory in South America called French Guiana. That's where the European space program launches from. The Russians can get at it from Baikonur or Vostochny, which is over here. They have two spaceports. And the Japanese can get at it from Tanegashima, which is right here. So the ISS is in a weird tilted orbit. The launches that go out of Wallops, right, are not flying on a 90 degree flight azimuth, right? Because if they launch due east out of Wallops at 45 or 37.8 north, thanks, Dan. If they launch due east out of Wallops at 37.8, it's going into a 37-degree inclined orbit. No, their flight azimuth, so the compass heading when the rocket launches, and this is the reason why rockets roll when they come off the pad, right? They're going to have to launch this way. The ISS orbit will go like this, right? Because when the ISS crosses the equator, it's 51 degrees inclined, right? That's a 37.8 degree inclined orbit. They're going to have to change the flight azimuth. And that's why, that's why there's those ranges that we have. There's corridors, there's tracks for the rockets that they can take. And certain tracks are easier to see. It depends on what track the rocket is taking. But that's all correlative to orbital mechanics. What type of orbit are you going into? Where's the final destination for your payload? Is it going to the ISS? Because if it's going to the ISS, it's either launching this way or it's launching that way. Your flight azimuth going to the ISS out of Wallops is not going to be 90 on the compass. It's going to be 45, right? Because they'll launch out over the water and then they'll take a left-hand turn and they'll match the ISS's inclination. Did you see the stuff about Baikonur and the Kazakhs? Yeah, that's being incorrectly reported, Vickers, and I have no idea why. Everyone's saying, oh, the Kazakhs seized all of the Soyuz equipment. That's totally wrong and completely false. They seized the Soyuz 5 pad. Soyuz 5 is a rocket that doesn't exist. The Kazakhs seized the Baytarek pad because the Russians didn't pay the lease on it. Baytarek was a former Ukrainian rocket pad, and the Russians are trying to bring their next generation Soyuz 5 to it. This was a deal well before 2022. And they haven't paid. And they let the lease lapse, so the Kazakh authorities seized it because the Russian space program at Baikonur is leasing land from Kazakhstan for their spaceport. What about launching out of Cali? I could get into that in a second. Yeah, it's the Baytarek project. So it's Soyuz 5, a rocket that isn't even anywhere close to flying. The Soyuz FG and the Soyuz MS pads at Baikonur were never seized, which is weird. It's weird that people would report that without saying anything or without looking into it. Yeah, they seized the Baytarek project. So yeah, ISS operations are basically unimpeded because the Soyuz 2-1, so the Russians launch a couple of different variants of Soyuz right now. They launch 2-1A, 2-1B, and MS. 2-1A and B are for cargo. Soyuz MS is for people. MS can launch Progress or Soyuz. So Progress would be an uncrewed resupply vehicle, or it would be the Soyuz with people on it. Pretty much, Serge, yeah. Mm-hmm. How relevant is being close to the equator for spaceports? Well, Kaharia, once again, it really depends on what type of orbit you're trying to get into. This is going to sound like one of those things that's like, oh, thanks for the pro tip, EJ. Yeah, obviously. Launch pads that are closer to the equator are better for getting into low inclined orbits. It's easier to get into a low inclination orbit from the equator. Launch sites that are near the equator are easier to get into an equatorial orbit? Wow, thanks for that shocking revelation. No, the reason why it's like that is because Earth is not a sphere. It's not a uniform sphere. It's like a big jello mold. And it bulges at the equator. It's not perfectly round. There's no. Oblate spheroid. It's kind of just like a big wobbly jello mold. And because of this, because the Earth is spinning, it bulges out at the center, right? And because it's bulging out in the center, your relative speed relative to the core of the Earth when you're spinning around because you're further away is actually faster. So you get a free velocity gain imparted on your vehicle when you launch from the equator. Interesting, right? It actually costs you less delta V to try and get something into an equatorial orbit from Kourou in French Guiana right there than it does from the Cape. Weird, right? Now, here's the thing. It's the reverse if you're trying to get into... So what's the other type of orbit? Why would you want to launch into anything that isn't equatorial like this? Well, there are other orbits that go north-south with an inclination of 90 degrees. So that means when the thing crosses the equator, you're 90 degrees perpendicular to the equator. And Apollo, that gets into what Vandenberg is for. Vandenberg is for going into orbits that basically go from 85 degrees inclined all the way to 127 degrees inclined. Now, anything past 90 is going counter to the Earth's rotation. So that's called a retrograde orbit, because you're going as opposed to a posigrade orbit or a prograde orbit, which is the way that the Earth is actually spinning, right? If you launch and the Earth is spinning that way and you launch that way, you get a velocity gain. That's why equatorial sites that are closer to the equator, are better for getting into equatorial orbits. Because once again, oblate spheroid, the Earth's big jello mold. And we're all floating around on the crust of a big jello mold. I hate jello. Oh, come on, man. There's always room for jello. So, you get a free velocity gain imparted on your vehicle. Now, here's the thing. For polar orbits, that's actually not good. The reason why is because if you want to get into the right polar orbit, right, you're spinning this way. You're spinning that way. You're going really fast going that way. You have to negate that velocity in that regard. So you have to kind of fly on some weird kind of dogleg trajectory. So if they're trying to get into a polar orbit from Kourou, or even from Vandenberg, it's not as bad with Vandenberg because Vandenberg is a little ways north of the equator. Kourou is pretty much right on the equator, right? It's like 2 degrees north or something, right? Trying to get into a polar orbit from there actually costs a lot of delta V because they have to negate out that imparted force that's making them go that way. So they actually have to, like when they go to launch, the target orbit has to be over here because by the time they launch, the rocket will look like it's doing kind of a curve like this because the rocket takes a little bit of a left-hand turn, right? Because the Earth is spinning underneath it. So you have to kind of curve the trajectory a little bit. Where do you work? Robellini, I teach people about orbital mechanics here on stream. That's my job. What are the red circles on the map? Ground tracking stations. I hate jello. Translucent, jiggly, and it gets everywhere. Velocity is speed. Yeah. What advantage does Alaska and Texas give? Well, Texas, they put it there. Texas, you can get into... You can't really get into many different types of orbits. They could go polar out of there. Texas, I don't know. Well, that remains to be seen. But Vandenberg is good for those polar orbits because there's nothing out there in the Pacific Ocean, right? Hey, Whitney, thanks for the raid. All right, so Alaska. Now let's think about this. If equatorial launch sites are better for getting into low inclination orbits, right? If you were trying to get into those polar orbits or those retrograde orbits, where would you want to launch from? It's not a trick question, guys. Seriously, if launching near the equator is good for getting into equatorial orbits, where is good for launching into polar orbits? From the poles. Yeah, I know. There's no tricks here. You don't need to. There's no tricks. There's no funky stuff with spaceflight. It's all very straightforward because it has to be because it's super freaking complicated. So, believe it or not, it's easier to get into a polar orbit from the poles. I know. Crazy, right? The reason why is for that same reason with the equator. This part of the Earth spins faster, and you have to negate that velocity when you're trying to get into a polar orbit from the Cape, from Vandenberg, or from Kourou, right? You have to negate that. When you're up polar, you're not spinning as fast relative to the center of gravity of the Earth. Because you're not spinning as fast, it's easier. It costs less delta V to get into space. You can do this in Kerbal 1, not necessarily in Kerbal 2 right now because we don't have other launch sites. It'll actually cost less delta V to get into a polar orbit from Woomera in Kerbal 1 than it does from the Cape, because the Cape, or KSC, because KSC is right on the equator. Woomera actually costs less delta V to get into a polar orbit than the Cape does because Kerbin is spinning just like Earth. Same thing. And you could put this to the test in KSP if you really want to. Yeah, pretty cool, right? So the U.S. actually has another launch site up here. You can't actually see it. It's off the coast of Alaska on Kodiak Island. And they use that for going into polar orbits too. You could do Vandenberg. Vandenberg is good enough. But yeah, you really don't want to try to go polar from here. But once again, you can engineer the rocket to do that. It's not a big deal. It's just a little bit more of a weird trajectory. But why is there not launch side, if I may ask? Misko, I don't understand. I know English is not your first language. What do you mean launch side? I wish Canada would enter the game of the launch site. Purple Haze, they want to build a launch site in Nova Scotia, bud. Does the momentum of the Earth spinning have any effect on the satellites rotating on the polar axis? Ah, interesting. Good question. Yes, absolutely. But it's not for the reason that you think. So, if you took the Earth and you kind of cut it in half, like you see that in like books and stuff, they cut Earth in half to show like what's inside, right? The mantle, the crust, etc., etc. If you took it and cut it in half and we were looking at where the geometric center of the Earth is, as opposed to where the center of gravity is, they're not coplanar. They don't coincide. The center of gravity of Earth actually kind of moves around the central rotation axis of Earth. So Earth is kind of this, once again, big wobbly jello mold floating around in space. That will absolutely affect an orbit. That force is called precession. Precession. So the non-uniform gravitational pull around Earth, because the center of gravity is spinning around the geometric center of Earth, right, causes satellites to move. It moves around. It's called an orbital perturbation. It'll perturb an orbit. Oh, absolutely. The crazy thing is, you want to see where this gets nuts? They figured out a way to have an orbit that uses precession, called a sun-synchronous orbit. And that sun-synchronous orbit basically makes it so the satellite shifts its orbit using the natural precession forces that we're talking about here to go over the same spot at the same time every day. Hence, sun-synchronous. What would be the application for an orbit like that? Anybody know? Why would you want to go over the same spot at the same time while it's daylight so you can see what you're looking down at every day? Yeah. Those spy satellites that you see in movies, that's the orbits that those go into. You know, we got another satellite coming into range now. Okay, zoom in. That guy's reading the newspaper. Yeah, that satellite. That's what those are. They use the Earth's natural precession to actually adjust the orbit over time and purposely put it into a resonant perturbing orbit that'll make it go over the same spot every day at the same time. Sun synchronous orbit. Pretty cool, right? Yeah, you want me to really blow your mind? The moon is the same way. Why do you think one side of the moon faces towards us all the time? The moon ain't spinning, but it is orbiting around Earth. And the center of gravity of the moon always is closer to Earth because it wants to get pulled in. The moon has precession if you're orbiting around it too. So we play a lot of KSP here. In KSP, you put something in orbit around the moon, it is going to stay there, no questions asked. But in real life, there's stuff that decays around the moon. Oh yeah, because the moon has non-uniform gravity. That's part of the reason why it's tidally locked. Stream, come back, please. It's part of the reason why it's tidally locked. You can have decaying orbits around the moon in real life. That absolutely happens. Oh yeah. KSP dude disagrees. Yeah, they're trying to fix that, Yarg. Here, let me give this a quick refresh. So the satellite's coasting, guys. The rocket did make it into space. She's coasting right now. Pretty cool, huh? Yeah, orbital mechanics is cool. But at the end of the day, it's all basic physics. Basically, if you're spinning in that direction and you're trying to go in that direction, well, you have a lot of momentum going that way. It's going to be harder to change direction. Think about it like a car driving down the highway. You can't take a 90-degree turn when you're going fast down the highway. No. If you try to do that, you have a lot of momentum that wants to keep going that way. And usually what happens is physics takes over and the car will keep going that way even if you turn the wheel. It's incredible that the moon is that perfectly synchronized. There needs to be a gap 2 centimeters per 1,000 years. Cesare, yeah, absolutely. That does happen. Yeah, the moon is, because of Earth's precession and the moon's non-uniform gravity and the Earth's non-uniform gravity and the Earth spinning in the direction that it's spinning, right? It's actually pushing the moon about this much away from Earth every year. Now, don't get me wrong. The moon isn't going to fall out of orbit. It's not going to get ejected into solar orbit anytime soon. Our star, the sun, will blow up before that happens. But it is moving slightly away. That's Earth's grav well. Earth's grav well is pretty nuts. I mean, you see how fast you need to go to get into orbit, right? Earth's grav well is pretty hefty for a planet of its size. We're going to lose the moon. Oh, don't worry. The sun will explode before that happens. Yeah. A couple bajillion years away. Actually, it's like 4 billion years away or something. What if we blow up the moon? Do you want climate change? Because that's how you get climate change. Yeah, you don't want to do that. That is an option, dude. I don't think that every nuke on the planet hitting the moon simultaneously at the same time is going to do anything to the moon. It's that big. You wouldn't think about it, but it's pretty big, dude. I mean, it's only 1/6 the size of Earth, but that's still a scale that's pretty incomprehensible. Heck, the size of Earth is pretty incomprehensible for most people. The Earth's freaking huge. I didn't say it was a good option. Yeah, all right, that's fair. Big as your mom? No. Your mom's as heavy as a neutron star, or as high mass as a neutron star. Got him. We're repairing part of the reason why Earth we have an atmosphere and that whole the magnetic field is kind of a little bit different. Part of the reason why we have the atmosphere is because the Earth's gravitational pull is pretty hefty for a planet of its size. I mean, consider Mars. Mars is almost the same volume as Earth, but it has like 1/3 the gravity of Earth. Earth is very dense for what it is. Yeah, Goju, she's a beast, man. Do rockets launch with or against the rotation of Earth? Why do they choose the way that they choose? Well, actually, Scripted, you must have come in late because I just explained that. You want to, if it depends on the orbit you're trying to get to, and that's part of the reason why rockets roll off the pad, because they'll roll and turn to a different flight azimuth. Your flight azimuth is something synonymous with compass heading. All right? So, this style of orbit, I'm not sure exactly what they're trying to do with this style of orbit. This might, this is a 37.8 degree inclined orbit because they launched due east out of Wallops. But, yeah, it really depends, dude. So I was talking about the ISS. The ISS is at 51 degrees inclined, meaning when they cross the equator, it's a 51 degree angle, right? So it's in that weird tilted orbit so it can get access from every single international partner. Us, the Russians, the Japanese, and the Europeans can all launch to it. That's why it's in a funky orbit like that. So that would require rockets to launch northeast. But you generally always want to go with the rotation of Earth because you get a free velocity gain, especially if you're close to the equator, right? Now, don't get me wrong. The higher inclination you go, the more polar you want to be, right? You want a launch site that's more north-south if you're doing polar orbits, right? But to get to the ISS, you get a free velocity gain if you're launching from here, for instance, because you're spinning with the equator. Now, don't get me wrong, sites, and I just said this, fellas, but I'll say it again for Scripted. I'll say it for you, dude. Sites that are closer to the equator are better for getting into lower inclined orbits. Sites that are closer to the poles are better for getting into higher inclined polar orbits or retrograde orbits if you wanted to do that, but it's hard getting into a retrograde orbit from something that's near the poles, but you can do it, sure. Yeah, Boom Player. No problem. Yeah, can remind someone shouting. Yeah, I know there's a lot of people here that don't speak English as a first language. That's fine. It's okay. Yeah, Hayes, absolutely. Pretty crazy, right? A little bit on orbital mechanics there, dudes. Orbital mechanics is cool, and this is the kind of stuff that you can go and visually see when you play Kerbal, which is actually really cool. It's one of the reasons why I love that game the most. Yeah, but Gene, they do. That's the thing. You're going to suffer a little bit of a delta V loss if you try to get into a polar orbit, because even a higher inclined orbit like the ISS, because you're trying to negate that spinning force. So the ISS is 51 degrees inclined. If you launched out of Kourou with a 51 degree flight azimuth, you're not getting into a 51 degree inclined orbit. It'll end up being like 45 degrees inclined. Weird, huh? Is Relativity still going tonight? Relativity is... No, they backed up a little bit. They are launching on Wednesday, the 22nd. Oh, 10 p.m. That's a late launch. That's okay. Not sure how Starship gets into orbit without overflying. You're getting darn close to the Bahamas. Well, Starship is going to go this way. It's going to go through the strait between Cuba and Florida. But another thing to take into account, guys, is that Starship, well, first of all, the launch corridor for Starship is going to be a little bit different. Well, why? Why is it going to be a little bit different? It's going to be a little bit different because the first stage, you don't have to worry about the first stage falling down. First stage is going to go back and land. So the launch corridor is going to be a little bit different. So Starship is more likely to be able to fly over populated areas. Now, the second part of that is once you start, you launch out of Texas, right? Boca Chica's right here. You launch out of Texas. I would say the flight azimuth would probably be, the flight azimuth range would probably be anywhere from about here to probably this way. With the exception of flying like directly over Cuba, I would not do that for pretty good reasons. One, I mean, first and foremost, if the rocket fails, you don't want debris falling on Cuba, right? Now, Florida, launching over the Floridian Peninsula is a little bit different. The reason why it'd be a little bit different is because if you're launching this way, there's only going to be a small determinate window right there of where that would come down over like Jacksonville or something. Now, don't get me wrong, you still don't want that, right? But they could terminate the rocket and the rocket could blow up before it even gets to that point. You're not going to fly a ballistic trajectory. You're not going to get up to here, have your rocket malfunction, and then have the debris shower the Floridian Peninsula. They'll blow up the rocket. Most rockets have a self-destruct system built in for that exact reason. That's called a flight termination system, right? So SpaceX probably, once, if Starship gets up and flying and they prove with data that it's not going to blow up and land on Florida, right? I mean, it could. There's always a risk, but if you prove the engineering out, the laws of physics don't tend to change, right? So they could probably get going from anywhere from like right here to like right here, if I had to guess, which is pretty damn good. That pretty much gets you into all orbits. Now, once again, I don't think that that's going to happen initially. I think Starship's orbital flight test will probably go this way, and it'll straddle the strait between Miami and Havana right there, or Key West and Havana, I should say. It'll go this way, and it'll probably do launching due east out of here will probably have you'll probably miss Puerto Rico, and go right down here like that. FDS works better than FTX. I would certainly hope so. Florida Man can take it. Dude, Florida Man would probably take a wrecked Starship and make his house into it or something. Local Man takes spaceship and makes trailer out of it. More news at 11. No, I love Florida Man. I lived in Florida. I am a partial Florida Man. That explains a lot, doesn't it? Ugh. Okay. Yeah, you could try to get the corridor in there, Squish, but then again, you're going over Caracas that way. I would not do that. That's probably not a good idea. You could try to do like a dog leg out the hole that way and then fly over the Amazon, but once again, you're going right over Caracas. That's a pretty big city. I wouldn't do that. I mean, maybe it's far enough downrange to not make a difference. But that is pretty Delta V intensive going this way and then taking a right. It's like that launch out of Tanegashima that we saw the other day where they launched due east and then took a right-hand turn. It sucks that the H3 didn't work. But the H3 basically launched this way and then did a 90-degree, took a right-hand turn in space. It drifted up into orbit, which is really cool, and then the second stage didn't ignite, which sucks. Why did they put it in Texas? They put it in Texas because SpaceX wanted a private launch site where they wouldn't have to worry about other customers launching. That's right, part Florida Man. Yep. Did I miss the update gameplay? Slavi, I'll be going back to it once we get confirmation of satellite deploy. It should be happening soon. They're going to fly over this ground tracking station that is... Where is that? Where is that station? That's not Perth. That's too far north to be Perth. Where the heck is that? Aussie Bros. Perth's down here, right? Or no, maybe that might be Perth. I don't know. Is it down here? I always thought Perth was down here. Yeah, Perth is further south. I don't know where that ground tracking station is. Yeah, Odic, they might, dude. I don't think so. Contrary to what you might think, most people in Florida understand what rockets are. Like, It's very funny, dude. Like, most people down there know what the rockets are because they see them launch all the time. So that's kind of part of the natural habit. They see, right now, that ain't no spy sat. That ain't no spy thing. That's a dang rocket going up into space. What, are you dumb or something, boy? Like, they don't all sound like that. Some of them do. Some of them do. I live there. So it's kind of, that's one of those funny things. Because you always think that, you know, the Florida man would see a rocket and be like, no! Shoot it! No, they're like, it's just another rocket launch. It's pretty cool. I'm like, yeah, it is pretty cool. I do like those. Those are pretty nice. Is this the 3D printed rocket? No, Repip. That's Wednesday. Hey, Scary. Dude, I couldn't get it running. Freaking peacock. How'd you do? Until one goes off in the ocean. Yeah, those, they know about those. Not cool was being woken up at 3 a.m. from the shuttle's sonic booms. And they were loud, Matt, that's for sure. Terran 1 launch, you know when? Joe, of course I do. I wouldn't be good at this job if I didn't know. And now, don't get me wrong, I don't know it off the top of my head, but it is, it's the 22nd, dude. So it's next Wednesday at 10 p.m. That's the tentative time. That could change. Hi from 43,000 feet, 19th to 5th. You went from 19th to 5th? Okay. That's pretty, that's pretty good, man. Did you reinstall it? I didn't, Blackness, no. How sweaty is that Artemis hat? It's fine. It was faded already, dude. Your thoughts on a launch site on the northernish Australia? A launch site up there could be useful, Aqualex, but you got to remember that's a super busy shipping range or shipping route. I mean, you're Navy, you know, dude. You were Navy. There's a lot of ships. There's a lot of traffic over here. You know, if anybody out there is 7th Fleet, you know what I'm talking about. There's a lot of ships out here. Very busy traffic lane over here. Qualifying happening. Here's a Pugat. It was a big Sendman for a straight hour. Big Sendman for a straight hour. Nice, dude. That's cool, man. Oh, that's cool, dude. That Pugat is flying. I know it's Peugeot. I know. Relax. Yeah. I'm not sure a launch site would be good over here. Heck, even the Chinese, the Chinese have a launch site, so on Hainan right here. And that, dude, even then, they can only really launch due east out of there. They don't want to overfly the Philippines. That would be bad. They don't want to overfly the Philippines, or they definitely don't want to launch north. It's just like how, for the longest time, launching due south out of Florida because Cuba is there was not a good idea. They want to be careful. This is Timmy's music. Zanku. Could that be the Carnarvon tracking station? I mean, we could go look on Google Earth what's there. There's got to be a city there. Alright, fine, we'll do this way. Everywhere, Scotsman. Huh? I'm willing to bet it's Geraldton, 99% sure. Alright, so that tracking station is over here. It's up the coast. Perth is down there. Yeah, I'm thinking it's over here somewhere. Let's look. Usually tracking stations are at like airports and stuff because there's nothing to get in the way of the antenna. There's the VOR for that airport. Look around for satellite dishes and stuff. Oh yeah, there's definitely something going, they're doing something down there. For sure. That could be it. I doubt it. It's probably power for the airport or something. Oh, dude. Short track. Hell yeah. Remember to take map distortion into account. Yeah, for sure. Yeah, it's like right at the point of my mouse cursor. We're trying to figure out what that ground tracking station is, dude, or where it is. It's somewhere on the west coast of Australia. Here, let's figure out where it is relative to like top and bottom right there. Let's see. We go top and bottom. It's about 2/3, a little over. Well, it's like not halfway. It's a little bit north of halfway. Halfway's right there. It's up here somewhere. Nah, it's got to be Geraldton. Your last lap corner. I think from memory, the tracking station there is halfway between Geraldton and North Gully. Look at this whole thing in there. Neat. Man, Geraldton's all that's really out there, huh? Yeah, that's too far up. It's got to be somewhere up in here. Basically 80%. Like there ain't much out there, huh? Could North New Zealand work as a launch site? Why, yes it could. Oh yeah. Rocket Lab, those are Rocket Lab's pads. This one launched out of Wallops. There are two. Note how Rocket Lab has 3 ground tracking stations in New Zealand. Yeah, absolutely, dude. Yeah, they launched it from the Mahia Peninsula up there. Yeah, that's their launch sites. It's the New Norcia Deep Space Ground Station. It's usually det cord that goes up the side of the rocket. Yeah, that's definitely it. Now, they're not using that tracking antenna. It's probably a smaller one like that. For that, that's a deep space antenna. That's something that could get you like out to the moon. That's a big boy antenna. We're talking like a 30 meter antenna. You don't need to track something in low Earth orbit with a 30 meter antenna. Something small like that would do it. Do they build the rockets in New Zealand? They build them in Long Beach, California, Kizek, so I can show you.
Discovery, go and throttle up.
Welcome back to the live webcast of Rocket Lab's 34th Electron mission, Stronger Together. I'm Likita Satrasala, and this is Felicity Powell, and we're glad you could join us this evening. Our mission has been by the book so far, with the vehicle lifting off at 18:38 local time or 22:38 UTC from LC2 on Wallops Island, Virginia. Electron passed through max Q, MECO, first stage separation, and second stage ignition before reaching the T plus 3 minute mark.
At T plus 6 minutes 16 seconds, the vehicle completed a successful battery hot swap, and then followed up with SECO and separation of the kick stage at 9 minutes 14 into the mission. The kick stage proceeded on its first pass of an elliptical orbit and is now completing that coast phase. Up next is payload deployment of those 2 satellites for Capella space. Let's take a look at this animated simulation of what that will look like and listen back with mission control.
Yes, let's. So that's not... I'll be honest with you guys. I simultaneously do and don't feel the need to say that that's just a compute 3D animation of it, but I also, for some reason, I felt compelled to tell everybody that that's not a live shot of it. But yeah, no crap. They don't have something floating around the thing to see a picture of it, right? Like, but also, yeah, so this is not live. It's obviously a 3D animation. Sometimes 3D animations are animated using the telemetry. That's not. This is just an animation. This is so like they'll play the deployment sequence on the animation, you know, when they hear confirmation. There's somebody playing the sequence that's synced up with the timeline of the mission, right? This is not like live animation, but there you go. There's the TwinSat sub.
Payload deployment confirmed.
There we go.
And that's Mission Control with the good news. We have successfully deployed Capella's satellites to orbit. And with that, we've completed our 34th Electron mission. A massive thank you and congratulations to our customer Capella and all of Rocket Lab's teams for another mission success. And of course, thanks to you and everyone who has followed along at home to share this moment with us.
This concludes our broadcast this evening, but remember to follow Rocket Lab's Facebook, Twitter, and Instagram pages for more information.
All right, cool. There you go. Stronger together. Dan, I'm surprised Australia hasn't done more space travel. What better country to go to a place where everything wants to kill you than a country where everything wants to kill you? I mean, space wants to kill you all the time. So yeah, Australians would be very good at spacing. There is a launch site in Australia. It's Woomera. It's actually right in the center. Here. To time the orbit correctly. So Woomera, Dan, there's a whole launch complex out here. Somebody actually even launched rockets here. There have been orbital launches from Woomera before. They would 100% feel at home on Mars. Yeah. Someone launched from Woomera back in the day. They launched a rocket, got it to orbit, and then said, nah, we don't need to do that. We don't need to go to space. 'Tis a silly place. Yep, the Brits. Yeah. Lipstick rocket. My wife worked there, and I've been onto that site. So yeah, there have been orbital launches from Woomera before. They, when the UK... So this was in the late 60s, early 70s with the Black Arrow rocket. They call it the lipstick rocket because of the red payload fairing. Why is it painted red? Don't know. I have no idea. Now, when England... So a little ways after this, for other reasons, England and France decided to... And all the other European nations decided to work together, and they made the European Space Agency, right? And after that... Britain said, all right, fine, we'll contribute to that instead, and they started building Ariane rockets. The Ariane 1, 2, 3, 4, all the way up to 5, and now in the future, 6. So that makes it so the Brits are the only country ever to surrender orbital launch capability. It's true. Lies! The British will never surrender. Bully! There are 2 more. One is for sounding rockets in the north, known as Arnhem Space Center, and one orbital site on the south, known as Whalers Way Orbital Launch Complex. Oh, that's neat. Yeah, Woomera isn't the only one. Australia's a pretty freaking big place. It's, yeah, pretty wide. It's about as wide as the U.S. is. About the same. But it's way more remote than the States is. I mean, how long is this across? Yeah, that's for all intents and purposes U.S. size. Blinga, how long would it take to drive from like Sydney to Perth? It'd take a couple days, right? And I hope you rationed your fuel right, because yeah, there doesn't seem to be a lot of anything out there. It seems like once you get past like here, Not here or here so much, but like this area here, it seems to be not a lot. Yeah, that whole red area likes. Yeah. Turn on roads. All right, let's see. ROADs. There we go. Now it loaded up the roads. So see, yeah, there seems like there's a lot of stuff go. That's not a real city name. You guys are making shit. That's not a real city name. That sounds like a Canberra. That sounds like the name of a circus. All right, moving on. Take a look at Uluru. That's the Ayers Rock. It's not Ayers Rock. It's Uluru. I get it, but yeah, okay, yeah, I got you. I've seen it before. Been to Dubbo. Dubbo is not a real place. Who would name their city Dubbo? So let's see. What do the roads look like out here? I assume there's one road along the coast, and that's about it. Yep. Any roads? Oh, there's one. And that road kind of basically stops when it gets to... I'm not even going to attempt it. I'm not even going to attempt it. No. All right, cool. Back to Kerbal. I hope you guys enjoyed the Electron launch. Back to Kerbal. Yep. It looks like Mars. It definitely looks like Mars. That's why we got to send more Australians into space, man. Well, Australians will set foot on Mars and be like, reminds me of home. All right. We can make this work. It reminds me, this is just like home. You know it's right. The Australian people watching are like, yeah. Yeah, that's cool, Gene. Seems like a cool place. I'd like to go there sometime. Yeah. Yeah. Yeah, exactly. What I'm getting from this is that Australia is prime for aviation enthusiasts. Yep. All right. Let's go.